Hello, everyone. Thanks for tuning in again. I'm Twain Taylor, editor at amazic.com. And over here on this podcast, we talk about all things Kubernetes, all things cloud native. And we talk to industry leaders and experts from various different organizations that are innovating in this space. So if you like this interview and if you like what you hear, I want to encourage you to head over to amazic.com and check out all of the other interviews that we've done, the articles, the event coverage, the job listings. There's a whole lot happening there. So without further ado, I want to introduce our guest for today. He's Dave Sudia. He's the Senior Developer Advocate at Ambassador Labs. Dave, it's great to have you with us today.
Yeah, thanks for having me. I really appreciate it.
So Dave, if you could just get us started with telling us a bit about yourself, your background leading up to Ambassador Labs, that'd be great.
Yeah, sure. So my first career, I was actually a special education teacher. I worked as a behavior specialist. And when I transitioned into development, I brought my behavioral expertise in. I started in testing and QE. I kind of went, oh, this is just a behavior plan for software. And being sort of on the operational testing end of things, I ended up making a pretty natural transition into DevOps. And I was a DevOps end user really for about 6 years. I worked at Fanatics, which is a sports merchandise company. I worked at a company called GoSpotCheck. At GoSpotCheck, I was really brought on to transition that company into, off of a platform as a service and into something we had a little more control over. And we went into Kubernetes, and it was a really exciting time to do that. Everything was very new. And we were trying to figure out the tools as we went and sort of build the plane as we flew it. And that was just a really great opportunity to see all these great tools developing in the space and sort of be there around the beginning of what is sort of now this popular movement around platform engineering. Got to do some presentations on it and do, it was a fun experience. So after that, I became CTO at a nonprofit called Upchieve. Upchieve.org. We provide still low free tutoring for low-income high school students, so through a web-based platform. And so that was an opportunity to take that experience and apply it to something where we had even more scale and something I was really passionate about as it melded with my previous experience in public education. And now I'm at Ambassador Labs, and I really came here because I've been using Emissary, Ingress, and Telepresence, the two projects that we donated to the Cloud Native Computing Foundation, since they were in version 0. And they're projects that I'm really passionate about, that I loved using as an end user. And now I get to go hype them to other people.
Right. Wow. Sounds like you've worn different hats across your career. And, It's not the first time we're having a chat. I remember having an interview with you a couple of years ago as well. And I could definitely see that, you have a great way of explaining these really complex technical concepts in really simple language. And I really like that about you. So, I wanted to ask about, as you mentioned, you started working with Kubernetes and this whole cloud native tooling since the early days itself. Could you sort of tell us which kind of tools have you worked with the most, or which part of the cloud native landscape are you most interested in?
Sure. Yeah. So I think the thing that I have been the most interested in, right, is how do we make this all easier for developers, right? Mm-hmm. It's coming into this position, even as a developer advocate. One of the things I've had to learn, like I had my use cases, right, but then I've had to learn all of the use cases, and that's always interesting. You're just saying about breaking things down comes from my background as a teacher, but I can get really deep in and get really knowledgeable about something, but I always have to remember there's sort of, the 1% developers and platform engineers and stuff who go really deep. And then there's the people who are just like, I'm just trying to get my job done. Yeah. Right. And so it's about like, how do we take these abstractions, or how do we take these really complex things and abstract them? And Kubernetes is fantastic at providing ways to do that, but it itself is very complex. And a lot of the tools built on it are very complex. It's one of the reasons I really like Emissary Ingress as a project, is that it itself is built on Envoy. And if you've ever read an Envoy configuration, it is something that's hard to read and you really don't want to write it, right? But it's very machine friendly. But Emissary itself was an attempt to sort of take Envoy configuration and make it human friendly, right? So that's, as I was trying to build a platform for our developers inside of GoSpotCheck and then later at Upchieve, it's about, okay, how do we find tools where the people who are wonky can get wonky, right? But the people who are not as wonky, who are just trying to get their job done and ship features, right? How do we make things easy for them to do and use and adopt, and be able to get their job done? That's kind of the key for me.
Yeah, I think that's a great point you made, because I remember even the last time we spoke, it was about service meshes, and we were contrasting sort of Istio and Linkerd, and you're definitely highlighting how, if you want to really get stuff done, Linkerd is a great choice. Although if you want to really, have it all, all of the capabilities that you may not even use, then Istio is the way to go. And so I definitely see that thread even here, where, you're very focused on getting stuff done, implementing the real world stuff, not just tech for tech's sake, but tech for solving problems. And I really find that fascinating. And, I really like that thing, that angle that you bring to technology.
Yeah, thanks. I don't know. I think maybe that just comes from being in small startups the whole time. And that's all you've got time to do is ship. So, yeah.
Yeah. So, we're going to be talking today a lot about ingress controllers. And particularly just Emissary and what's its position in this space. What does it do? So if you could get us started with just the basics of what is ingress in Kubernetes and why is it important? Something as simple as that, if we could start with it, would be great.
Yeah, for sure. So if you create a Kubernetes cluster and you deploy things inside of it, the networking inside of the cluster generally is really good. I mean, there's some things that service meshes add, and we can maybe touch on that a little bit later, but it's not that hard to deploy a couple of different services inside of a cluster and get them talking to each other, right? You create a service inside, and there, even without the service, you can do service discovery across pod IPs, and generally that part pretty easy to get started with. Getting traffic into the cluster from outside is a little more complex. It's not super complex, but it can get architecturally complex, and there are some easy to hit foot guns where you can really mess yourself up. So I remember when we were trying to figure this out early on, right? We started with, okay, well, every app gets a load balancer, right? And then that rapidly gets expensive as you realize that you've just reserved 500 static IPs, and there's all sorts of these things that sort of float around that idea. So the idea behind Ingress and Ingress controllers in Kubernetes is generally, and I'll say that the model that I just mentioned, having a load balancer for every service, you can do that with an Ingress controller, right? Like that, it's just a way of getting traffic in. But generally, where the pattern that I tend to see is that people want to provide one Ingress, right, where all traffic comes in, and then that Ingress controller routes traffic to the correct services. It's a lot simpler architecturally. Like, if there's a point of failure, you kind of know where it is. It's not always just a single point of failure. There's ways to make it, robust and redundant. But it also, you can get much easier observability out of that, because that controller can provide metrics that go, to your metric systems and traces, and that, all the sorts of the observability components. There's just a lot of advantages to sort of having a central place where you intake traffic and then route it correctly down into the rest of the network.
Mm-hmm. All right. Yeah, I think that really sets that's the stage. And you mentioned a lot of key components that we'll dig into in a bit. But before we get there, I wanted to just ask, do you have an example that you usually share to sort of bring this from real life, an example that kind of, anyone who's even not very familiar, who's just getting familiar with Kubernetes would actually get it? Do you have an example
totally
like that?
Yeah. So the last organization I was with, Upchieve, we had pretty simple structure, right? Like we were pretty small. We were a nonprofit, so we didn't have a ton of money to throw around at cloud resources, and so we had a cluster. We ran development, staging, and production environments in that cluster, and we basically had two apps. We had a container that served up a static site, like written in Vue.js, and then we had an API server that was written in Node, TypeScript, and so we needed that for development, staging, production, right? These, but multiple copies. So now you've got essentially 2 applications across 3 environments, and each one a couple of instances each, right? Well, now how do I get web traffic from users into those places, right? Like, and this is a small, conceptually small kind of thing, but already we're hitting these levels of complication, right? We've got horizontal scaling. And so, and this service had REST traffic, it had WebSocket traffic. There were different kinds of protocols in play. And so right off the bat, it's one thing to just like, and everything was on, even the 2 applications were both on like app.upcheap.org, right? So you have one host, and now we need traffic to get split between protocol, between places it needs to be. And so that's where it really helps to have a thing that is configured to correctly route traffic and say, ooh, if it's coming in here, you're going to want to let WebSocket upgrades happen, right? WebSockets are long-lived, so they can't just go to any random pod in the cluster. And one of the things, Kubernetes by default will just load balance traffic anywhere, right? So now we need to stick these connections to these pods. So that's kind of, I mean, it's like a simple architecture, but even at that simple architecture, you need something that is intelligent about how traffic gets routed and enters into your cluster. And so, what that looks like then is you have a service that's a load balancer, and that might it's like a public facing, like Google or Azure or AWS load balancer, right? And that traffic comes to those pods. That is the ingress, and then those things can intelligently make decisions of, ooh, this one goes to dev, this one goes to production, that one's a WebSocket, right? That one's gRPC, that kind of thing.
All right, so that gives us a great overview. If you could talk a bit about CRDs, that's something that we hear a lot about, custom resource definitions in Kubernetes. What are they, and what are the CRDs that help with traffic routing? And if you could give us some examples as well.
Yeah, for sure. So the way that Emissary handles routing, and there are other examples of this too. Nginx has ways that you can do this, and I think a lot of the major ingresses do now. But basically, what we were talking about abstraction earlier, right? Like, how do you take this complex configuration and make it more human friendly? And so the way that Kubernetes really offers to expose that is custom resource definitions. You can set your own, YAML configuration and say, all right, give me information here. I'm going to take it and make it more, turn it into some deeper level config. And so the way that, Emissary gets configured in particular is we have this CRD called a mapping, and the mapping exposes things like, if if you recognize that the traffic comes in on this host name or on this path and on this path, on this type of protocol or with this parameter or whatever, then route traffic to here, right? Like, this is the service that should receive, the internal service that should receive that traffic. And so what that allows teams to do is put in their own routing definitions, right, without having to go to some central team. And it also allows you to keep those things in code, right? It's not a button you're clicking somewhere that can get lost and you forget how to do it, or you don't remember exactly how this thing got configured, right? It's there in the cluster itself. It used to be that, like, in the very early days of Emissary, we did mappings as a service annotation. And what we realized was that service annotations are too easy to lose, right? You got to get all services and grep out some kind of thing from the mapping, or you try to figure out where they are. There's no validation that you can apply. So CRDs are really helpful within the cluster for traffic routing, because you can validate them, you can find them. Ideally, you're also keeping them in Git somewhere in a way that you can apply them regularly, and we can dive into a lot of these things, more deeply.
Yeah, and I want to just ask about, the kind of challenges that teams face when working with ingress controllers and just traffic routing generally as well. What are some of the challenges that you see?
Yeah, totally. So I think one of the first challenges is just provisioning, right? So one of the things that drives teams towards a central solution is that if I'm an individual like developer team, right, I'm working on microservices A, B, and C, then if I want to stand up a load balancer for each of those things, right, the things that cost money tend to be things that you need approval to do.
Okay.
and so the more that you're having to have developers create infrastructure, the more you're going to slow them down, right? So I think that's one of the first things that pushes teams towards a centralized solution. Once you get to that centralized solution, though, the thing that slows down is now you have a bottleneck, which is the team that owns the centralized solution, right? Which tends to be the DevOps team. I know it's not a team. Don't at me. But in a lot of places that's what it is, or the platform team or something like that, right? So now they own this ingress, and other teams, to get anything done, right, like let me put in a ticket to get my route for this new microservice or whatever. And so that's really where decentralizing the configuration was a driver. Like I said, the point of Emissary is to speed up developers. And it kind of does that by making things more convenient for platform, right? And so if developers can drop mappings into the cluster, then when they need to spin up a new service, they just spin up a new service, right? That CRD can sit alongside the Helm chart that deploys the app, or the customized project or whatever it is that is the deployment code essentially, and it just rides along and can go right in, and the configuration is immediately reconfigured so that traffic can start coming in. And so that it's like, it's sort of, okay, how do you reduce friction for developers by reducing the amount of infrastructure they're responsible for? And then how do you reduce friction for developers by removing bottlenecks in the process? Those are the two most common things I see.
Yeah. Okay. And different tools in the space, attack this problem from different directions. I was looking at the list of options for Kubernetes ingress controllers, and it's a huge list. It's probably like more than 20 of them.
Yeah, I'm sure.
You mentioned the centralized ones. So if you could sort of give us a kind of overview of the landscape right now. Why are there so many options? How are they different? How do you make sense of all of these? How do you pick? How do you know which one is the right one for you?
Sure. Yeah. I obviously I'm a little biased. And I'll try to talk around that bias, right? I think like different ingress controllers have different features, right? So there are some that are more focused around security. There are some that provide WAF-like features. There are some that we all integrate with different other products, right? And so some of it might be driven like, oh, well, we've already made the decision to adopt X, right? So now when we're looking at ingress controller, the things that are going to work best for us are Y and Z. And yeah, so I think as you're, and this I think this is the same kind of thing I'd say for when we talked about service meshes, right? Is it also kind of comes down to Conway's law in a certain sense of like, how is your organization structured, right? Is it not that big of a problem? Because at some places it isn't, if there is a central team that manages all of that central, ingress config. You may be a place that doesn't want developers to just be able to create their own routing, right? And so, I think like that's going to influence like what tool you pick. The other piece of it is performance, right? I think each of the ingress controllers out there, or not each of them, but there are sort of groupings of controllers that have different strengths and weaknesses. I'll say with like Emissary, Emissary works the absolute best when you have a small number of hosts and mappings, right? We can handle a lot, but it just kind of influences, our particular performance is influenced by large, and I'm talking hundreds to thousands of host names and mappings, because every time a request comes in, we have to figure out like, okay, which mapping fits this incoming profile, right? So if you have lots of different options there, that process just takes up more CPU. So, going and looking at the benchmarks for each of the controllers can really help you pick, right? Some are going to be stronger in certain scenarios versus other ones. and yeah, I'd say those are kind of the main things, like what fits with the tools you have, you know, in the ecosystem you're creating, what matches your organizational structure, and what matches your, like, which has the best performance parameters for your actual situation, right? I think are the three main criteria you're looking for when you're trying to pick one.
Mm-hmm. All right. And, related to that as well, I see that Istio has its own ingress controller. Um, and, so if someone, let's say, thinks, I've already got, I'm already using Istio, or I'm already using one of the other ones, like the API management services like Kong or Tyke, and
Sure.
they have their own ingress controllers as well. Um, you know, um, do you see any difference or do you see the standalone ingress controllers having an advantage over these integrated ones? Are there differences?
Yeah, I think so. And I'll say that, like, Emissary integrates with Istio, right? Like, we can actually sit in the mesh. We basically mesh in the pods with Istio, and it just takes over, and then it takes over that portion of it, right? Like, we still handle ingress, but then we're part of the mesh, so the traffic instantly is meshed into your larger system. I mean, I personally, as an end user, was always a fan of purpose-built tools, right?
Okay.
Like, it's why I ended up with Linkerd. It does the mesh, right? It's why I ended up with Emissary. It does the ingress. So I'll say that even beyond being, a representative for Emissary, like, I'm biased that way. And I just acknowledge that, right? I think that the reason I lean that direction is just because things that are purpose-built, there's the full brain space of the people building it is taken around, like, how do we solve that problem, right?
Yeah.
And so with Istio, I think it fits a really good it fits a certain organizational structure. I also I know someone who just the other day was, okay, we weren't even talking about this topic, but they're kind of like, I've been trying to set up Istio for 7 months and never successfully managed to do it. And I think it's just the challenge of those really complex, like, it's whenever you're making any kind of API, there is a balance between exposing power, right, and customizability, and making things easy to do, right? And so I think, like, Istio is a project in particular that leans towards, we're going to give you the power to do anything you want, but then doing it is just proportionally more difficult. You kind of have to have someone who's like, I'm an Istio expert, right? And so yeah, I think even within that space, you can take these projects that do all of it, right, and then use the parts that make the most sense. But if you find a purpose-built tool that maybe does a piece of it better, right, then you can always drop that in, right? And I think that's the biggest thing for me about, like, this is why I try to stay in the CNCF ecosystem, really, is because at some level they all play well together, right? And it's a reason that, like, when I was trying to figure out what's my next step, the first place I went and looked were, ending up at Ambassador Labs. The places I was looking are like, where are the places that have donated projects to CNCF? Because I like being able to represent the project itself as much as a company, but also the tools play well together. And if they don't at the moment, they probably are on the path to doing that. And so that's the other thing for me of using these open source projects versus the fully closed source projects, is just that they tend to much more like, here's the ecosystem we're pushing you into, right? And the open source projects are like, hey, we're part of this ecosystem. I gave a keynote in 2020 at KubeCon, and the whole point of my keynote was, you get to pick, right? Like, there's all kinds of options and solutions out there, and you can compose them. And it's because the teams put in effort, right, to be good neighbors in the ecosystem.
Yeah, I think that's a great point on the ecosystem. I think it's definitely a golden age for open source in general, and just the kind of options that we have. And I think it's a golden age, not in the sense that it's getting worse, but it seems like it just keeps getting better with just the kind of maturity, the kind of cooperation, even among vendors. It's really great. It's just a great time to be doing this kind of stuff now.
Yeah, for sure.
And yeah, great point you made about just not being afraid of picking best of breed tools than having a fully integrated solution. I think that's pretty much what the industry is moving towards as well. Best of breed, standalone tools that are great at what they do and work with the others equally well. Some
Yeah.
really great points you made there. Um, brings me to Emissary, and I just want to ask about if you could take us a bit back to the start of Emissary. Why did it start? Was there a need, and what was the need it was trying to fill in the space? How did it get started? And just since that time, how has its role evolved in the space?
Yeah, totally. So I touched on this earlier, and this is actually a thing I learned a couple weeks ago. I was talking with Flynn, who was one of the original developers of Emissary and is still a maintainer. He's now over at Buoyant, actually, working on Linkerd. And I was asking him kind of basically that question. And so it's sort of thing I've already said, which is Envoy is hard. and Emissary is the user-friendly version of Envoy for API gateways. That was the intent of the project, is how do we take this super powerful tool and make it friendly for humans, specifically in that context, right? And so a lot of effort has gone into the mapping CRD, because I mean, there are other CRDs that we have, hosts and TLS contexts and other stuff that essentially allow Emissary to figure out like what traffic should I accept, but the mapping is the key one, because that's like, oh, I've accepted this traffic, now where do I send it? And it's the hardest one because of the stuff I mentioned earlier, right? Like you've got protocols from HTTP1 to HTTP3 with gRPC in there as a special breed of HTTP2 plus WebSockets plus all these different things. And so plus just plain old low level TCP traffic or UDP, right? So that's the challenge, and that's the one where we continue to sort of every time we have an update be like, have we exposed too much? Have we exposed too little? That's the place where we balance, is trying to make sure that we're keeping it human friendly while exposing as much power as we can. And so yeah, that's kind of where it started, and it's been interesting to go on the journey with the project, being an early end user up to now. I started my first deployment of Emissary was 0.31 in April of 2018. And we're on 3.x now. I should know this, but I think 3.1. And so, yeah, I mean, as I think early on, you could basically do host name and path, right? That was basically what you could choose to direct traffic. And as we've gone on, there's been TLS certification management. There's been, all the various protocols that have been added. There have been not borrowing, but, like shared lessons with other projects like Linkerd around, for gRPC traffic in particular, because gRPC is also a long-lived connection based on HTTP2. That was another one where Kubernetes internal native load balancing of gRPC is not that great. And so a lot of the service meshes have a focus on that, because a lot of gRPC traffic tends to be internal to the network, but it was also a place where we picked that up and went, okay, this is another quality of life thing that we can do for connections coming through the ingress. How do we take those and also provide better solutions for that? So yeah, it's really been going from that simple place to this very complex place of in terms of features, but the core has always been walking that line of how do we make this just human friendly enough, but also just powerful enough.
Mm-hmm. Yeah. And you mentioned a bit about centralized traffic routing and decentralized. If you talk a bit about Emissary's approach on that versus something like an Nginx, centralized versus decentralized.
Yeah, totally. So with Nginx, there is a central config, and there are ways in Kubernetes to not have one 1,000-line long config file. There's a similar kind of conception of dropping in individual files that it then recompiles into. But at the end of the day, there's one centralized config, and it's kind of, I think, oriented around that team structure, that architecture. And yeah, and I'm, again, like whenever I talk about projects and I'm comparing them with the projects that I favor, I'm not trying to talk badly about them, right? It's really about comparison.
Yeah.
because they're great places where there are solutions for.
Yeah.
So
Yeah.
with Emissary, I think the place where it's best is when you have autonomous development teams. And I think more and more places are shifting that direction, right? Like, how do we empower developers? How do developers own their app from, testing through post deployment, that sort of thing. And yeah, so having the ability for teams to just drop mappings into the cluster and have routing happen immediately is really where Emissary shines. You drop a mapping in, basically what happens is each of the Emissary pods independently owns its own internal version of the Envoy config. So they don't have to talk to each other or come to a consensus. Basically, they are constantly scanning and reading the cluster for looking for new mappings to pop up. And as soon as a mapping pops up, they take it, they recompile the Envoy config and go. And so it's not exactly instantaneous, but it's pretty close in terms of being able to launch new things. So, I think there's a couple of advantages there as well. The other one is just that when there is a centralized configuration, I've seen some of the Ingress controllers just take time, that they take a long time to reload, essentially. And so, we've seen and heard complaints, I guess, around like adding a new service kind of causes the world to stop. Like we have milliseconds or even seconds of downtime, essentially, while the controller tries to recompile and reload itself. And so I think that's another thing where Emissary really shines, is that even when we do have hundreds of thousands of mappings, it recompiles pretty much instantly, and you go.
All right, all right. And coming back to that point you made about just the ecosystem and how tools are built these days to work with the other tools, and one of the the ideas that I see talked about a lot, as you mentioned earlier as well, is platform engineering, and just this whole Git Ops model as well. That's based on Git as the source of truth. And I want to just ask, how does Emissary fit in with that whole model of platform engineering and Git Ops?
Totally, yeah. So because everything is a CRD, right? It can be kept in code, and the model that I think I've seen the most often, and that's true for the platform team and for development teams, right? So we have, like I said, mentioned earlier, there are some CRDs that are sort of more for the platform-ish people. For the most part, they're going to be the ones setting up DNS entries, handling certificate management, there's a couple things there that are sort of global for the cluster, or common, right? And then the rest, and then the mappings really can kind of live with the developers. So how much you abstract that, and where you use GitOps for that can kind of depend on the team. At Upchieve, I was using Pulumi infrastructure as code. And so the way we kind of split it was in our Pulumi code, which set up the cluster, which set up all the tooling like Emissary and Linkerd and Argo and all these sort of internal things. We kept the host and TLS CRDs, those were sort of in that code. The mappings lived in the Helm charts for our applications. And so even though we were just one team of a couple of developers and we sort of we all managed everything, like even in that sense, we sort of split the GitOps portions out. It was still all in Git, right? But like where it got controlled was a little bit different. But it was really nice. It's, again, that's one of the great things for me of having the GitOps model and having CRDs be the resources, is that if there was any question, what's the timeout on that, right, on that path? Because we had like a report path that took way longer than the chat WebSocket, right? What's the timeout there? How are we routing traffic there? What parameter are we looking for? It's just really easy to go see. And then any changes that we made still went through our regular control flow. So adding a new mapping, updating an existing mapping, these things all happened in the same deployment path as deploying a new container version, right? Like there was still a PR, there was still approval. It went through the rollout process. We could roll it back really easily we were using Argo CD to deploy. And so, yeah, you had the full control that you would expect out of, any kind of production deployment system, but for traffic routing, which to me, that's really rad. Like, I have as much control over the network as a developer, essentially, my personal chunk of the network, as I do over my app.
All right, great. And, so for someone watching this, everyone's at different stage in their journey when it comes to Kubernetes and cloud native. Some are probably at the early stage, just, getting started with the basic setup, and some, probably running Kubernetes since 2017 or so. Um, um, when do you think that, someone was watching this, what are some of the signs that, they should opt for an ingress controller, a standalone one, or a certain kind of one that they may not be using that they should take advantage of?
Sure.
What are some of the signs?
I mean, I think this decision kind of needs to get made pretty early, right?
Mhm.
It's one of the, at Ghostbotcheck, we didn't adopt a service mesh for about 1.5 to 2 years in, but
Mhm.
API gateway was one of the first things we needed, right? And so I think it's one of the building blocks for the rest of your system. And again, that's another reason I moved more towards the piecemeal, purpose built tools, is then you don't have to adopt an entire system all at once, right? It's like you can, oh, we need that, we don't need that yet. But yeah, I think like you spin up a couple clusters, you deploy a couple things, you're really rapidly going to run into the same thing, I ran into when I was doing this, which is like, oh, we can't be spinning up like external load balancers for every single thing we put in here, right? And the moment that you go beyond a couple of services, the moment you go beyond, a couple of environments, really, I think just naturally teams are going to start wanting to look for a solution that handles that problem. I think even at Upchieve, we could have used, I theoretically could have just had 6 load balancers, dev, stage, prod, for the 2 services that we had. But even then you run into issues of, and I think this leads to the other criteria maybe, which is like, how complex or just particular are the protocols you're using, are your services using? If you're using anything other than HTTP 1.1, like if you're running a Java monolith on HTTP 1.1, you actually may not need an API gateway, right? Right? Like you may just be able to put a load balancer in front of it and go, and then stick, Cloudflare or Fastly or something in front of that. Like you get your WAF, you got the ingress, and you're set. And there are totally scenarios where I think that's reasonable. The moment you start getting into other protocols like WebSockets or gRPC, at that point, that's the other time you should really be starting to look for an API gateway solution. And an ingress solution is just because Kubernetes doesn't handle those things, doesn't handle long-lived connections very well in its native traffic routing. And so that's where you're going to want to start looking for, if it's sitting right behind the edge, ingress controller, if it's something internal, service mesh, just to handle those scenarios.
All right. Wow, those are some really good pointers. A lot of very practical and actionable takeaways there. We're winding down just the last few questions. I want to ask, someone who's listening to this, getting excited about Emissary, wants to participate in, what's happening. How can they get involved? What's happening with the project?
Yeah, so we're on GitHub. It's an open source project, and we're at github.com/emissary ingress. This is another thing I should probably just know off the top of my head. /emissary-ingress, and you can find the relevant emissary projects there. And then also we have a Slack that's a community Slack that you can join, where we talk about emissary and telepresence. We have emissary dev channels that are public that you can join if you're interested in trying to get in to contribute or maintain. The maintainers are there. We have regular weekly meetings where you can chat with the maintainers of Emissary that you can join by joining the Slack. And just a whole community of people who are really friendly and want to help people figure these problems out as they go along their own journey.
All right, very cool. And so Emissary is the open source project, but then you also have something that is a paid version, Ambassador Edgestack is what it's called. Could you tell us a bit about this and what advantages it adds on top of Emissary?
Yeah, for sure. So Emissary is extensible. It can handle a couple of things like authentication at the edge. It can handle rate limiting. But Emissary, the project itself, basically has an API for those things. So it doesn't have a rate limiter built in. It doesn't have an authentication system built in. But because there's an API, you can write your own authentication service, right, that it can speak to. You can write your own rate limiting service that it can speak to. The two main things that come along with Edgestack, which is sort of the larger product we've built around Emissary, are we give you authentication, we give you rate limiting built in. There are also certain things that we're limited in the sense that like we're not allowed to reship the Acme library that retrieves Let's Encrypt certificates within the open source project. So you can do certificate management with Emissary, but with Edgestack, we will automatically provision TLS certificates for you using Let's Encrypt. So as you stand up a new host, you can just say, you know, I'm at app.company.com and I want a certificate for that, and we'll just go get it and handle it in a couple seconds, and you don't need to really manage TLS certificates anymore. Within that, we also have a product called Ambassador Cloud, where if you have Edgestack, you have that as well. And that sort of acts as like a place to wrangle all your services. So people can add annotations to their services in the cluster, and you can kind of come in and see like, the owner of this service is X, and here's a link right to the Slack channel where I can go ask questions about it because it's getting in the way of my service or something. And then we have metrics and stuff that show up there. So it's sort of like a management hub for all the services in your cluster as well.
All right. And how does pricing work? What's it based on?
Yeah, it's based on number of clusters, and it's based on number of requests per second that are going through those value added services, right? So I was an early customer of Ambassador after I was an early user, and our pricing was relatively low because we weren't actually using the authentication or the rate limiting features. We were basically paying for support. And that's one of the things I like about our pricing model is that, you know, if I told you pricing is based on requests per second, a lot of places are going to freak out because they're running, 5,000 requests a second or something. But it's really only requests that are being authenticated or being rate limited. So that's, it's sort of like as you move up in adoption of the tool, in the same way that's like, all right, I'm only adopting this part of my ecosystem my tooling at this point, so you can adopt our pricing model as you move forward with the features. And you can actually start. There's a free tier that is one cluster and up to 5 requests per second, again through those services. And then there is sort of a team tier that I believe is $3.99 a month. And then it moves into contact sales. But yeah.
All right, cool. Last question for you, Dave, is what do you see in the future of API gateways for Kubernetes? What's happening? Where are things going?
Yeah, totally. So I think the most exciting thing happening right now is that not recently, a while ago, I guess now, but in this ecosystem a year or two ago feels like 100 years.
Yeah.
But Kubernetes stabilized what they called the Gateway API, which is a set of APIs you can make back to the Kubernetes server that really kind of defines like how do you create an ingress, right? How do you create something that is going to take traffic in? There are a couple of projects within CNCF that are trying to tackle gateways based on Envoy, right? Ours, VMware makes Contour, and so there are a couple of projects, and we are now trying to collaborate across companies, across maintainerships, across user companies on this project called the Envoy Gateway project, and that is really like to take Envoy and evolve it in a way where there are configuration APIs that are compatible with the Kubernetes Gateway API to really make it easier to manage Envoy as an API gateway. And so several of our maintainers of Emissary are working on that project in collaboration with the others. And I think that's really exciting just because, again, it's the thing I love the most about this ecosystem, like we're talking about, right? It's like, it's all these people who are just coming together and going like, we could do this our own way, but it's just going to be a lot friendlier for everyone if we just get together and figure it out together, right? And so, yeah, it's my favorite part of this industry, and this corner of the industry is when teams get together to make things better for each other. And I think there's a real opportunity there to get more performance, get better ease of use for everyone, and further standardize onto, you know, I don't know, it's that XKCD comic of like, I think there should be another standard. Now there are 13 standards kind of thing. And it's like, oh no, hey, look, everyone's actually consolidating around one. This is great. So I'm really excited to see that.
All right. Yeah. Wow. This was an amazing conversation. Just thanks for taking us. Just giving us the 30,000 foot view, as well as just going down into the details of how traffic routing and just ingress controllers work and what's happening in the space. I think it was just really insightful. Just loaded with a lot of good stuff. Thanks
Thanks,
so
I
much,
appreciate
Dave.
it.
That was really great.
Yeah, thank you
So
for having
before
me.
you go, I have a couple of fun questions to sort of get to know you a bit more. And the first one asked to everyone that comes on the show, your alternate career path if not for your job in tech.
Teaching. I mean, it's why I like this. It's why I think that's the common thread of every position I've had. Even as a, you know, as a platform person, I was having to teach developers, you know, about this stuff. And yeah, if I win the startup lottery, you know, in an exit or something, and don't have to work again, I would probably just go back to public school. Yeah.
All right. Yeah, no surprise there. I think that totally makes sense. And the second question, the one work tool that you can't live without.
Oh, there are lots. Yeah, I think so. I don't know. The most recent one is this is a tool I had not used a lot, but internally here we use Notion, sort of as the internal knowledge platform, and I've like played around with it a couple of years ago and kind of went, I don't get this, and dropped it, and now I really totally get it, and it's so nice having everything in one place and being able to structure things however you want and being able to look as a table or a board or whatever. So Notion's my current. Ooh, this is I'm excited about this tool.
Yeah, absolutely. I love how we can build stuff there.
Yeah.
Complete the sentence, open source is.
I think open source is a legacy, and legacy is a much maligned word in tech. You know, it connotates old, and I don't want to have to work on that because the people who built it left 3 years ago and no one knows how it works. But no, I think, you know, the way I think of it is companies come and go. You know, standards coming, like it all comes and goes in this industry, right? But I think open source is a way to ensure that your work lives on, right? Like it's a way to ensure that we've all cooperated on something, and everyone gets to use it, right? And so I think like that's what I love about it is that like the project lives, and you can get multiple perspectives on it. You can get, you know, as you bring more people in to work on it, it grows and evolves, and I think that's what open source is to me.
Yeah, I think that's really insightful. To add to that, I'd say even open source projects themselves come and go. But I think just
Totally.
the attitude of open source, just the movement itself is something that is not going to go. That's going to stay.
Yeah, no, I think that's a really great point, Twain. And I think, but I think the thing for me there is like, okay, that project died, but I can grab that bit of code from it, right? Like there was a really great idea in that thing, right? And like, it's even so. I don't know. A really like specific example for me is at Upchieve we have this whiteboard, and we kind of wish we had a better whiteboard. And so, you know, there was a company that actually that made this whiteboard that went out of business, but open sourced their whiteboard when they went out of business. And we weren't able to just grab that and use it. But actually Nextcloud, the folks who sort of make like the open source Google app kind of competitor, they needed a whiteboard, and they used that whiteboard. That's now the whiteboard that's in Nextcloud. And they like picked up this project that had completely lost all maintenance, like updated it and put it in their thing. And we were able to go look and grab ideas out of it, right, for how we were going to build one. And so it's that, like, even if the project dies, like it still lives in a way, right, in the ideas that you're able to share with others.
That's true. It's fascinating lineage, I think, when you trace back projects and, you know, where their seed ideas come from. I think that's a whole other space in itself.
Yeah, for sure.
One hobby or interest that you picked up during the pandemic?
Mountain biking. I was one of the many people in Colorado. I live in Denver, who picked that up. I think it was just a way to get out, outside and theoretically away from other people, although the trails ended up being pretty backed. But yeah, got that. And I've got a son who's 7, and so he was 5 when it started, and so he got into that with me, and we go out and bomb around trails now together.
Wow, sounds like fun.
Yeah.
The last question for you, where do you get your updates from on what's happening in the space? Which website or forum or platform you read up on the most?
Yeah, totally. I browse Hacker News pretty regularly. I think that's a good way to just sort of, a lot of projects get launched to the public there. And it's there's just kind of a broad range of topics that get posted there. In terms of like CNCF stuff specifically, actually the CNCF Slack is a great resource, free to join. And a lot of the projects have moved, like the Argo project, I think build packs, they like move their channels from a discrete Slack over into CNCF Slack. And then all the technical advisory groups, the tags, have channels there. And so even if you're not part of a tag where you're actively going to the meetings and contributing, I kind of like to just like lurk in the channels and occasionally pop in and kind of see where the discussions are going. That's a really fun way to learn stuff about like the Gateway API and that sort of thing. It's just kind of, I don't know, it's an open, transparent communication place, and so you can just kind of go, it's like you're standing next to a group of really cool people like listening, eavesdropping a bit. So yeah, CNCF Slack's another main resource for me.
All right, cool. And I'm sure that a bunch of people watching this, they want to connect with you and eavesdrop on what you're up to. How do they do that? Where do they connect with you?
Yeah, totally. So I am at the developnik, which I can send you to put in the notes for the podcast, on pretty much every major platform: GitHub, GitLab, Twitter, you name it. And that's a great way to reach out to me. And then my email is dsudia, DSUDIA @datawire.io. And that's if you want to reach out to me directly and ask questions. I love talking to people.
All right, awesome. Great. With that, we draw to the end of this fascinating conversation with Dave. And I hope all of our viewers, you enjoyed this conversation as much as we enjoyed having it. So definitely check out Ambassador Labs, check out Emissary, the open source project, and do connect with Dave if you want to know more about what's happening there. Also encourage you to head over to amazic.com, where we have a lot more conversations and stuff like this that you'd love to follow. So definitely head over there. With that, we come to the end of this podcast. Thank you for joining us. And thank you so much, Dave. It was great having you.
Yeah, thank you. I always love talking with you, Twain. And last thing, since you mentioned it, is Ambassador Labs is at getambassador.io.
All right.
And that's where you can visit us. But yeah, I love talking with you, Twain. Thanks for having me.
All right, great.